Hi, this is the first video of a two-part series on binomial expansion, and in this series, in this particular video, we will focus on expanding binomials using patterns, which in my opinion is the more important lesson of why we study binomial expansion. I'm going to go very quickly here, so don't be afraid to use your pause button. If we take a look at this screen long enough, I think you'll see that there's a lot of patterns that emerge when we expand binomials. By the way, a binomial is two terms that are together, as opposed to something like this. This is a trinomial. A term is anything with it's a number, it's a variable, or a combination of them. So this has 1, 2, 3 terms in it. So we'll be focusing on just binomials. If we look at what's going on here, we see that the first term of a binomial always starts off with the same power as the binomial itself, and then starts counting down, right? X to the fifth, fourth, third, and then the second term doesn't appear here because it's to the 0 power, and then the first power, and then actually the powers count up, and then the numbers, they seem a little bit random, but there's some symmetry here, and as it turns out, we can find these numbers using Pascal's triangle. Pascal's triangle is generated by a triangle of ones, and then every row underneath it is made up of the sum of the numbers above it. So let me do this for example. So if I wanted to do another row here, I could start off with a 1 off to the side here, and then 1 plus 10 is 11. Write it in between, and then in between these two numbers, 10 plus 45 is 55. And then 45 and 120 is 165, and so on. So we would keep on going all the way across, and then the next row after this we would start off with a 1 off to the side, and then 1 plus 11 is 12. We'll write that in the space in between the two numbers, and then we would just keep on going. Alright, so that's how Pascal's triangle is generated. We see applications in Pascal's triangle in probability and now in binomial expansion. So if we wanted to expand this binomial, what we would do is we would take a look at the power here of the binomial. It's the fourth power, and what we can do is we can go to the fourth row of Pascal's triangle, starting with 0. So the 0 row, 1, 2, 3, 4. So this is the fourth row of Pascal's triangle. So we would write these numbers down: 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. Put spaces between them because we're going to fill in these spaces with more parts of the term. So these are the coefficients. The next part comes, we need to fill in the first term. So we remember that the first term start off with the same power as the binomial. So right here we will write x to the fourth, and then it counts all the way down to x to the 0. And then the second term, the y term here, starts to the 0 power and then counts up. Since we have a plus sign here, we're going to put plus signs in between all the terms. We simplify. Anything to the 0 power is 1, so we simplify and we get this as our answer. So this is the expansion for this binomial. Let's do two more examples. What if instead of just an x here, we have a 2x here? Well, again, we are to the fourth power, so we're going to write the fourth row of Pascal's triangle, the numbers here, and then instead of starting with x to the fourth, we're going to write that whole term, 2x to the fourth, 2x to the third. We'll count it all the way down. Y here starts off with 0 and then counts up, and then we add our plus signs, and then we simplify. So don't forget that to simplify this term, 2 to the third is 8. 8 times 4 is 32. Alright, so we have expanded this term, this binomial. Now, this is the last example, and it's the same as the previous one, but we have a minus sign here. So what do we do with that? So again, we start with the fourth row, the coefficients, and then we use the first term here, 2x to the fourth power, so that'll be the same. We count it all down. Now with the y, it's easiest if we consider the negative as part of the term. So we do negative y to the 0 power all the way up to the fourth power. Ran out of room over here. And then we add plus signs between all the terms. Now if we simplify, we get something like this. And you notice that any time that the second term was to an odd power, we get a negative sign. Right? And if it's to an even number, we get a positive sign. So we see this alternating pattern: positive, negative, positive, negative, positive. All right, and so that's it. That's how you expand a binomial using patterns in Pascal's triangle. In the next video, we'll talk about using the binomial theorem. All right, thank you.